Kingston, Tennessee, a city with a high precipitation rate and a temperate climate, with warm and humid summers and cool, wet winters. The city is adjacent to the Emory and Clinch rivers, the latter of which flows into the Watts Bar Reservoir. These bodies of water are slightly polluted from industrial, agricultural, construction, and mining activities in the area. Still, the rivers are viable for fish, such as the bluegill sunfish, the red ear sunfish, and the largemouth bass. The rivers also contain phytoplankton, not that they can be seen with the naked eye, and flows over bedrock composed of limestone, dolomite, and shale. If you were driving through, it would be hard not to notice the towering smokestacks of the Kingston fossil plant. Constructed in 1955, this coal-fired power plant is operated by the Tennessee Valley Authority, or TVA, and uses low-sulfur coal, catalytic converters, and scrubbers, specifically electrostatic precipitators, to reduce harmful gas emissions of nitrogen and sulfur gases. The plant produces as much as 300,000 tons of waste yearly, with the capability of powering over 700,000 homes. This coal fly and bottom ash is mixed together with water and allowed to settle in a pond before being moved to a storage cell where the water is evaporated, just by the Emory River. It's December 2008. Barack Obama was just recently elected to be the next president. The holiday season is near, but this is also a year of crisis for the country, and you don't want your quality of living threatened.
Industry claims that coal is clean.
There's a heck of a mudslide or something that just came through our backyard.
A dike at a coal plant gave way this week.
Sludge suddenly burst through a wall, sending 1.7 million cubic yards of it, enough to fill 520 Olympic-sized swimming pools, into the surrounding neighborhood and into the Emory River. From that spot, it's only 5 miles downstream to the Tennessee River, the source of drinking water for millions.
Up to 400 acres remain polluted. The potentially toxic slurry burst through a holding pond wall at the Kingston fossil plant Monday, destroying 3 homes and damaging many more.
We had no reason to believe that it wouldn't hold this.
There are also fears about arsenic. If inhaled, it can cause cancer.
This was not a natural disaster.
Hundreds of dead fish have residents concerned.
This was a man-made disaster.
The damage goes far beyond nearby homes and farms. The entire area's economy is in ruins.
On December 22nd, just before 1 a.m. Eastern Standard Time, the decades of built-up coal ash spilled into the Emory River, flowing 4 miles upstream and 7 miles downstream into the Watts Bar Reservoir. The 4.1 million cubic meters of coal ash affected about 300 acres, flooding houses, roads, and rail lines. A major gas line was ruptured and power lines were destroyed. 54 properties were damaged. Of them, 26 were homes, one of which was pushed off its foundations onto the road. Miraculously, no one was killed in the incident. Coal ash is known to contain heavy metals, which are unsurprisingly toxic to organisms in high amounts. An analysis was conducted on the water samples in triplicate and from different locations, employing a plasma emission spectrometer instrument to measure these metals. Samples collected on December 27th were found to exceed the aquatic life and drinking water guidelines for many metals. Here's the data that was collected. And here's that data averaged with the standards of deviation, where each note about water quality is highlighted. Between winter 2009 and spring 2010, the TVA used hydraulic dredges to remove as much as 8,000 cubic meters of coal ash per day. The heavier particles were allowed to settle, dewater, and were transported to a landfill in Alabama. This moved about 60% of the coal ash from the river. In January through March 2009, another analysis was conducted on the river water and on the sediment, starting at the shoreline and extending about 4 miles upstream of the Emory and Clinch. On average, the river water samples did not exceed the EPA's maximum contamination level, or MCL, guidelines for aquatic life with the exception of arsenic. Nearly all the water samples contained arsenic in excess of the human health MCL. Unfortunately, the samples were collected near the river's banks, so the figures presented may actually lowball the true concentration. A follow-up study was completed in June 2010, finding similar trace metal concentrations, with the higher concentrations being found in the pore water of the sediment, increasing with depth. Once again, only arsenic exceeded the MCL. In 2014, another analysis looked at the sediment, this time at the spill site and 1 mile upstream, finding the sediment to be 78% coal ash by weight at the spill site and 46% about a mile away. Compared to uncontaminated upstream samples, these deposits of sediment contained higher amounts of arsenic, selenium, and mercury. This same study that was looking at the river sediment was also looking at the metal ions effect on the river fish, looking at the metal absorbed through the gills and diet, as well as analyzing the reproductivity and development of fish across locations and time since the spill. Black bass catch rates at 2.5 miles out on both the Emery and Clinch rivers were the highest to date in 2015, indicating no long-term risk imposed upon their population by the spill. The Oak Ridge National Laboratory, incidentally enough the institution the Kingston fossil plant was built to provide power for, conducted a statistical analysis on fish reproductive data for the maternal transfer of metal into eggs from between 2009 and 2013, and found the coal ash unlikely to create long-term risk to fish reproduction near the Watts Bar Reservoir. The bioaccumulation of metals in the fillets of largemouth bass, bluegill sunfish, and red ear sunfish was also looked at. Selenium concentration dropped off over time for the bass and the bluegill, yet not as much for the red ear sunfish, likely the results of its diet. Selenium concentration in milligrams per kilograms of weight was found to be below the level of concern in all species for all years of study. The same could almost be said of mercury concentrations, except 2 samples collected from largemouth bass exceeded the EPA human health fish consumption level. This is likely not a result of the ash spill, as these anomalies occurred in 2014. It was concluded that the metal content of the river water had no long-term negative effects on the larval development of fish. However, it is still possible for the metal to threaten the microbial ecosystem of the rivers. A study conducted in 2016 collected water and sediment samples from 7 contaminated sites and 3 uncontaminated sites. In the water samples, trace metals were below the detection limit, and only manganese exceeded the EPA human health guidelines in 2 locations. Trace metals were actually found in higher concentrations further away from the spill site, most likely to be attributed to other industrial activity and not the spill. Arsenic and cadmium exceeded sediment quality guidelines. During the summer, the upper layer of the river becomes warmer and richer in dissolved oxygen. This makes the lower layer a reducing environment, decreasing the pH, which allows for the leaching of metals, as metals are more mobile when reduced in acidic environments. Conversely, the carbonate in the limestone bedrock increases the river water's pH and alkalinity. The pH ended up being measured between 6 and 9. On a neutral pH of about 7, trace metals are insoluble and adsorbed to the surface of sediment. To know just how much carbon comes from bedrock, the total sample of the carbon can be compared with the carbon sourced from organic matter and bedrock using a mass balance. These 2 sources of carbon can be distinguished isotopically. In fact, another part of the study was using isotopic composition of sediment to distinguish between carbon, nitrogen, and sulfur deposited naturally and anthropogenically. These elements cycle through the biosphere, lithosphere, and hydrosphere in predictable paths. Mass spectrometry is used to measure this precisely. The isotopic composition of carbon, nitrogen, and sulfur in combusted coal residue is different from that of organic materials and coal before combustion. This is useful given how abundant organic materials are due to the flora of the eastern Tennessee area and the phytoplankton in the rivers. Sulfur and oxygen can be used to identify sources of sulfate, whether that be from sulfur oxidation, soil, or acid rain. Sulfate isn't a big concern when it comes to the issue of contamination, but it is linked to the degradation of water quality. Sulfide oxidation can produce sulfuric acid, lowering both the pH and the concentration of dissolved oxygen, and can potentially harm the aquatic ecosystem. Microbial sulfate reduction, MSR, uses sulfate and organic carbon from the surface and sediment pore water to produce hydrogen sulfide gas, which reacts with the metals to form insoluble sulfides in a process known as bioimmobilization. However, this method requires sufficient sulfate and dissolved organic carbon concentrations. The removal of about 60% of coal ash within the first 2 years in conjunction with the natural processes helped decrease the amount of trace metals in the riverbeds. However, in an acidic environment, the trace metals become more mobile. The TVA's big spill damaged a lot of property that they ended up buying. Let's go back to that night. What happened? Well, the TVA hired AECOM to investigate what could have caused the spill. The TVA limited AECOM's investigation to stay blameless and not liable. AECOM had concluded 4 probable causes for the dike failure: fill geometry, increased fill rates, soft foundation soils, and loose wet ash. Except the TVA plant personnel visually inspect the ash ponds daily. The engineers inspect more comprehensively every year, and the Tennessee Department of Environment and Conservation inspects quarterly. How could there still be an issue? As it so happens, the TVA was aware of red flags surrounding the ash pond's integrity and did nothing about it. In 1985, an internal memo by a TVA engineer raised concern regarding Dike C. It was not built according to its design drawings. In 2004, 2 consultant engineers reported concern with the ash storage stability, yet modifications were not made. TVA's Enterprise Risk Management Program did nothing. In 1987, the Manager of Policy, Planning, and Budget had concern over the water's containment in the dike. In response, the Safety Office Coordinator prepared a memo stating that the dike should be part of the dam safety program, yet they never were. Upon closer investigation, it turns out that the TVA has a culture issue among its employees. Ash was poorly maintained, there was a lack of policies or specialized training, as well as a failure to follow best engineering practices. The employees at the TVA were resistant to professional care, treating ash more like garbage than the hazardous product that it is. Remediation cost over $1.1 billion and took almost 6 years. To make matters worse, during the cleanup effort, the TVA contracted Jacobs Engineering for help. Many workers are suing the TVA and Jacobs Engineering for breaching their duty to inform employees of hazardous conditions. Without proper personal protective equipment, many former workers suffer respiratory illnesses and a higher risk of cancer from toxic and radioactive metals in the coal ash. Some former employees have already had their lives cut short. Despite the incident being over a decade ago, the aftermath still looms over them to this very day.
It's got what it takes.